All right, we are starting up, I believe. All right. So welcome. This is going to be the second session. We're going to basically the second session of us doing ADTs, basically using Redux with the state monad as our root reducer. And I don't know, I guess we'll just jump into it. So let's jump over here to the code, and the first thing we need to do is let's create a new branch, and we'll call this 0x01 so it matches this. And you can get this code from the repo that should be linked down below. And all you do is just check out, when this is all said and done, you can check out this branch and get all of the fun stuff that we have or that we put in. So we have no one watching right now, but for the sake of the video, we'll just continue on. And I'm going to try to make this very, very regular. So we're going to be doing this every Tuesday night at 6:30 PDT or Pacific time. So it should be a blast. I'll try to make it very, very consistent. And yeah. So let's see what we got going on. This week, we're basically going to add the ability to add these tasks. And we're going to we left kind of a mess, not really a mess, but we took a lot of time to get things working in the first episode of this. So what we're going to do this episode or session or whatever you call these is make this a little more towards the pattern that we're going to use for the rest of this. So last week, we just did a bunch of stuff to get it, how would you say, working, just so we can see kind of what data would look like as it flowed through this model. So this week, we're actually going to kind of add a couple helpers and but solidify the way that our data is going to flow through these reducers. So if we look here, and we'll just go over what we did, okay? So this is your normal React app. But one of the things we're doing, and hold on, before I do that, oops, let me jump over here and we will do E, and we want to bring in home.vimrc and just make a quick change here. Where is the ale? All right, so we have our ale stuff here. We just want to make sure that, yeah, so I will just do this real quick. That way the linter bar doesn't keep intruding on our space. Oh, good. So we have 2 people watching now. Welcome. Thanks for coming. Hope this is fun. But now when we open stuff, notice it doesn't open the linting gutter. That way we can kind of save the space that we have. So we have this directory structure, and inside of here we have our normal reducers and an index to actually load those in. And this is going to be our root reducer. So what we want to do is have all of our reducers, when everything's said and done, we want to return a state and then execute that state with the previous state. So if we look at a reducer, what that gets us is, notice, if we were to look at React's reducers in that example, Tom Harding, by the way, is awesome. Oh, hey, James. How are you doing today, sir? If we were going to look inside of the Redux example, goodness gracious, do you even know what you're doing? We jump here, and it was the to-do list, right? Examples, no. Let's go back to good old Googs, and this is what we actually want. So if we were to look at the typical reducer, notice the reducer takes some sort of state in and then an action. Well, in this flow, we're not concerned about the state, because we're going to create these lazy flows that just define how our state should transition based on, the action that's being sent to it. And then from there, we're going to give that back. So in the reducer, we don't really mention the state or care about the state in any way, shape, or forms. Oh, cool. Hopefully it'll be fun for you, James. James says, hi, all good. And then with a nice little jelly smile. And then looking forward to seeing this. So that's pretty awesome. I'm really sad they took the jelly emoji off of, what are you trying to say, Ian? They took the jelly emoji off of Slack. We have fun with those jelly emojis there. Anyway, one of the differences that you'll notice here is we're actually taking in an action, but we're not doing anything with the state. And then we pass that action along to these functions that are defined in our models, right? We still do the switch case and things like that, but we'll go ahead and get rid of that with a couple little bits that we're going to do. And then here we actually take our payload, we bring that in. So this toggle to do is our action creator. And all we're doing is using this to create an action that the rest of our system could use. No big deal. This is just simple Redux stuff. So the thing you'll notice, though, the thing that's important is you notice we're not even mentioning the state or passing it on to our reduction functions. So we need to have all of this. We need to have our reducers, how would you say, not namespace. So if we were to use the combineReducers, if we go here, combineReducers, that comes from Redux itself, we're going to run into some problems because this has an opinion of that it namespaces everything. Because we want our internal state to, our state monad to actually deal with the state as a whole, we still want to combine the reducers, but we don't want to inject that opinion in of where it actually namespaces it. Don't get me wrong, it's really amazing in most cases, but it's not going to work for the case that we want to do. So we need to make our own combineReducers. So we do that here in helpers. And again, this is just a quick review, and we'll go through this more as we kind of clean this up. But here in our combineReducers, all we're going to do is use this mconcat map function. And what mconcat does is it takes a monoid. In this case, we're using the first monoid. And it's going to, since we're doing the mconcat map, it's going to take everything in our foldable, which is basically our list of reducers that we're passing in. Right now, it's just to do. We're just going to take in those, and then we're going to do this run reducer function on it. And this is going to see if it's actually a state. What it's going to do is apply the action to the function that we get back, the reducer, and then it's going to check to see if it's an actual state. And if it's a state, we're going to get back a maybe or a just of that state. If it's not a state, then we're going to get back a nothing. And then the way that first works is it can take a maybe as an actual constructor argument. And when it has a maybe, it treats that as if I get a nothing back, it's considered an empty value, which means nothing hit it. But if it gets back a just, and it's the first just that it gets back, well, what that's going to do is always return that just. So as we reduce on our reducers, it's going to find the first just that we pick. And the reason why we can do that is because we're removing that namespacing. So if you remember before, if you've used Redux, a lot of times, say I have something else that needs to respond to a different part of the state, I have to have my action types available so I can include them in. So say we had some UI stuff that opened a modal, but we controlled that on something else other than the to-do, then we would actually take that action name or that type and we would handle it in the UI namespace. So we end up with action types kind of peppered all over our stuff. Well, we don't need that anymore. So that's why we're able to just take the first one, because we can take the state as a whole. We don't have that namespacing. But by doing, and then when everything's said and done, we option this out to a state of action. So basically, since we're not going to be working on the internal state, what we need to do, or what we'll do, is just return a state that can be run. Now, again, this isn't very, very nice. We should be doing a couple other things here to kind of take this disjunction and move it down, but we just wanted to get this to work. So now that it's working, we're going to go through, kind of add some how would you say, type signatures to these and see if we can deal with the types a little bit better. Okay, so I mean, that's basically what's going on. So anytime that we call this to do, right here with this toggle to do, and that's set up right now to be called anytime we click this, it goes ahead and it runs this toggle function. Now this toggle function is going to return a state, right? And let's just jump down to toggle. And right now we are having this function called map-to-dos. And what map-to-dos does is we have this other little helper called prop array that's going to check an object, in our case the state, and pull that property off. It's going to check to see if that thing that it got back is an array, and if it is, it's going to return it and adjust. If it's not an array, however, or that doesn't exist, then we're going to get a nothing back. So from there, we'll get our nothing, but we can then send our map function, and actually, I think we, hold on, because that doesn't make sense. We don't have a maybe there. Let me just jump into helpers real quick, and let's look for prop array. Oh, I see. It pulls it out of the maybe. So here we option this out, and we pull it out of the maybe, so we just get an array back. So if this key doesn't exist, or if this key exists, and we check to see if it's an array, if it is, we return a just. Otherwise, of course, this chain is going to turn it into a nothing if this doesn't pass. And then we're just going to option it to an array. So if we get nothing back, if both of these criteria aren't met, this prop exists and the value inside of that prop is not an array, we'll get a nothing and always return array. So that way an empty array. So it gives us a reasonable default, which is something that it's a technique that, we use in JavaScript. Reasonable defaults. They're the best. Okay. So what we do there is we pull that off, and then we have a mapping function that we lift inside of it and then run it against that array. So if we look at our mapping function, here we're going to do a flip complete. And this will map over and update our record using this title. And it's going to negate the completed. So that's basically what turns this from true to false and false to true. Okay? So that's our first action. This time, we're going to add another action. And while we're at it, let's jump out of here, And what do we want to open? What's our, not to do, you silly goose. We want to go, oh no, this is where we want. Okay, so we need to add a new action here, and we're going to call this add to do, okay? And this will be a way to add a to do, and it'll get the payload. But notice we're doing a lot of copy and paste here, and it's mostly just to match this. So since we have a nice little pattern here, we can go ahead and abstract that now. So let's do that real quick. So we'll jump into our helpers. And up here, we're going to create something. Let's put this here. No, R comes after that. So let's do an export default. And if anyone has any questions, please feel free to throw it in the comments, or I'm sorry, in the chat. And I can totally stop and answer any questions just to make sure that we're all understanding what's going on here. So feel free to ask questions. So we're going to take this default and let's create something called createAction. And this is basically just going to be a real simple action creator. This real estate really makes me sad. So let's do one of these, and we'll jump down here, and here we'll do DataReducers to do. And then now we'll just do it like this. Okay. So let's create a createAction. And what we need to do here is take some sort of string. So we're going to call this type, right? And then with that type, we need to then take a payload. All right? So we have our payload. And then all we really want to do is just give something back that's type payload. Perfect. And now we have a way, createAction. Why is that? We need to do const. Thank goodness for export default const. export const. What are you doing, you silly goose? So let's start adding some types to this. Since this is going to be a function that's going to stay around a while. We're going to take a string, which is going to be our action. And then we're going to take a payload of some a. And then from here, we're going to return back what's called an action. Okay? And let's just define an action just so we can put this in, we can just call it out as action. We'll say that an action is defined as an object that takes a type that is a string. Okay? So it's more like a record type. And on top of that, it takes a payload. And that payload could be any type A. So sometimes it's going to be an object, sometimes it's going to be a Boolean in some cases, but it can take any type A. And you know what? We'll call this an action of A. And just so it makes sense to, when we want this to be a Boolean or something specific, if we define it as action A, we can always just say what the action A is. Okay? So basically, all this thing does is it takes a string that it's going to create the type or the namespace out of. Then it's going to take some A and give us back an action of A. And we only do this just so we don't have to copy and paste this all over the place. We just put in these little comments so it's easier to follow what's going along. All right, so now we need a add to do. And add to do is just going to be add to do, just like that. And we can bring now in our import. And we're going to do import createAction. Okay? And that will come from helpers, right? So now we can get rid of this and just do createAction. And we put in toggle to do. All right. So now we don't even need the payload. We don't need any of that because that is a curried function. So we can just do this. And that should work. Let's see if it still works. Boom, boom, boom. Yep. So we're now using the other little helper function that we made to create these. So now we have something that matches our pattern. We can now get rid of this. Let's not get rid of that. Let's do F2P. And oops. And here we'll just get rid of that. Paste this down. And now we'll have add to do, which will really just be, add to do. Okay, so now our linter's happy. So this is working out pretty gosh darn nice. Let's just make sure that we're still good. I'll move my microphone here. And we are still good. Beautiful. All right, so the next thing we want to address, we put this together pretty fast, right? So like this combineReducers and this thing that we're doing, it's kind of weird that we're having this run reducer function whenever, I don't know. So I'm thinking our reducer. So let's define something called a reducer. And we'll say that a reducer is a function that takes some action. Okay. So now we'll put this here. And really what we want our reducer to give us back, because if we look here, if this type does not give us something back, so if we don't have something in this reducer function, we're basically, if it's not handled here, we return undefined. So in this case, we are returning either undefined or we're returning a valid state. So it makes sense for the reducer itself. To me, that sounds like a maybe, right? Does that sound right to you guys? So really what we want our reducers, the signature for them to have, is a maybe that returns a state that gives us back our app state. And we'll define app state later. There's no point defining that now, but just consider app state to be the state that is defined by React. Okay? And any questions or anything so far? We got a little bit of lag here, so I'll just keep checking the chat. If there's any questions, if I miss you or something like that, it's probably something to do with lag. So I'm going to just continue on. And if you feel like interrupting, feel free to interrupt. All right, let me take a little sip of juice here. All right. All right, so what we really want is our reducer to take some sort of action and then return back a maybe of state, of app state, and we could say A here, but for now we'll just make it unit. Because we don't really use the resultant in this, we're actually using the execute with, which only cares about the state portion of the state function, of the state monad, right? So here we have this. Let's just clean that up a bit so it's divided there. All right, let's make sure we don't have any weird bugs. Just putting comments in. You never know these days. So now that we have this, I wonder if this looks better. Let's see how this looks. Actually, that looks pretty good, so we'll leave it like that. Now that we have this create action, it's going to be kind of hard here if you think about it, because we want these functions to actually return a maybe so they match this signature here. And we don't really want to put the maybe in. And I'm not a big fan of switch cases or things like that. So what we could do here, all right, bear with me for a minute. How could we do this? All right, so what we can do here is actually, since we have this create action, let's create another helper, okay? And we'll call this function export const createReducer. So now what do we want this to create? What do we want this to create? All right, so we want to be able to capture this maybe in here. We already have it to where it's returning a state, right? Because these functions return a state. We need to, oh, you know what? Okay. So one of the ways, if you remember object-oriented programming, one of the ways that you can deal with not using these is a switch case or something like that, is you can use what's called the strategy pattern, right? And what the strategy pattern does is it lets you at runtime decide what function you want to use as a strategy for a given set of parameters, which is exactly what we're doing here. So what would be really nice, okay, let's just see what this would look like. All right, so we'll say const reducer is equal to, and we'll say createReducer, right? So what we would really like, and we'll bring in createReducer from here. Okay, so now we have our createReducer. Ah, we got people dropping off. So sorry, I must have been very boring. So what I would like to do is just be able to toggle our to-do, or to have that, and just put in the function that we want to associate to this action name, right? So I would like to define it like this. And then from there, take an action in. So if we have this function reducer, reducer is going to take in an action, which we defined over there, and give back our maybe of state. Basically, it's the same function, the reducer, it's what we have defined here, basically, right? So how could we do this? So we're going to need a function that first takes in, and here we'll actually do reducer. Okay. And we don't care about this anymore. We're going to get rid of that. So we'll use this to do our strategy pattern. Okay, now I'm going to save this, but it's going to error, of course, obviously. But that's okay. We'll get it up and working here in a little bit. So we'll take our createReducer. Now that that's saved, we're going to take our createReducer and let's do, we'll call it strategies or strats for now. Okay. We'll take our strategies And that's going to be that object that we pass in. And then we're going to take our action. All right. And then from there, let's go ahead and just call prop on our strategy. Here, let's actually destructure type and action or payload off of the action. So what we'll do is use type as the key. So we're going to check this. Prop takes a key, then it takes some data or like an object or an array. And then if that value is on there, it's going to give that back to you in a maybe. If it's not on there, it gives you a nothing back. So this will get us our maybe that we're looking for here, right? Goodness gracious. That'll get us our maybe that we're looking for here. So that should help us out. All right, so here we're going to take that and we're going to run that against our strats or our strategy. So now this should get us our maybe back. Now another thing we could do here is now that we have it, remember this needs to be a state. So instead of having our state check here, let's go ahead and chain in this down here. Okay? So now what that's going to do, and anytime you see a chain inside of one of these, what that's doing is applying the effect of the chainable. So in this case, it's a maybe. So the effect that we're applying is the disjunction. We're either going to have something or we're going to have nothing. So if this prop doesn't exist, this will be a nothing and just skip over this and return a nothing. By using this chain, what we're doing is we're telling it, hey, I know you have the value. Go ahead and pull the value out of that other maybe. Run it against this function. And if everything's good, return a maybe. If it's not good, return a nothing. So it gives us the ability, you could think of it as nested ifs. So if this is true and this is true, give me the just. If either of these are false, give me a nothing. And this is just how you would represent that type of flow using, say, a maybe like this. And again, you'll notice we use chain in our just and things, or in our state. And it's the same thing. The only difference is the effect on the state monad, whenever we call chain on it, is interacting with the shared state. Okay? All right. So now what we want to do, if everything's good, we should have a function in there. And this is not where we want this chain, because this should give us back a maybe with a function in there. So what we want to do now is apply our payload. Now, a lot of you might be thinking, oh, hey, you know, that sounds like an applicative, right? Maybe, hopefully that's what you're thinking. And mechanically, you would be correct. Like that is mechanically what you would use an applicative for. But to me, I think it's doing things like that just because you have a function in that side seems like an abuse. And this is just my opinion. Seems like an abuse of the applicative. The applicative is a lot more cooler than just being able to apply functions, right? Parameters to functions. It's the ability to combine already existing things. Well, since we don't have a maybe, this payload isn't in a maybe, to me it doesn't make sense to lift it into a maybe to apply it using the applicative or the the apply function or AP. But what we can do is keep it in JavaScript and just use this apply to function. So what apply to is going to do, if we put in apply to and then put the payload in, what it's going to do is give a function back that's ready to accept another function. And then it's going to take this payload that we have here and it's going to run it against that function, returning the result of that function, right? Now, if we were to do this like with AP, sure, we'd have to have a function or something in there, but we need to then wrap this in a maybe or a just. So it seems weird to lift this into a just to apply, whenever I could just use map and lift in a JavaScript function. And that's what I mean by it seems like abuse just to go ahead and do it that way, in case you're wondering, okay? Now, the other cool thing about this is now we should have, because these functions, remember, toggle and all that, if we look here, I hope I have types in here. Oh, goodness gracious. Let's look at the models. Oh, and I don't. Of course I don't. So if we look at toggle, toggle should take some sort of payload. In this case, it's going to be an object, right? So toggle is going to take in an object, which is the payload for this specific thing. And it's going to give us back a state of app state and unit. Okay? So this is going to get us this part of the reducer. We got the maybe by doing all of this chain and mapping, and then after we apply it, that function is going to move it inside of here. Does that make sense? If you got any questions, if you want explanation on this, let me know. I'm going through this kind of fast, and I don't want to leave you behind, because to me it's kind of cool and beautiful how all of these algebras and these methods just work out. So please, if you have any questions or anything, please let me know. And I have people dropping, so I wish I would have said that before, and maybe they would have asked questions. Goodness gracious. But that's okay. You can't please everyone all the time. All right, so now we have this chain. Now that we have the actual state that would be in here, and so now that we have the actual state that would be in there, we're going to check to see if it is a state, because this requires that we have that, right? So let's go ahead and pretty this up just a little bit, make it a little easier to read. And I'm noticing some things here that we could, for instance, this, instead of using this fluent style, we can go ahead and take the strategies and just load that up as data. We'll keep it as this fluent style for now, but for the most part, I mean, we could get around it. Yeah. Okay. So now that we have that, now that we have this chain, we actually have something that when we run it is going to give us back a maybe that has our state in it, right? So let's look at what combineReducers is. If we look at combineReducers, it is a function that takes an array or a foldable, but in this case, we're just going to say an array. We're going to take an array of reducers. So reducer. And now that we have talked about that here, let's move this up here. Okay? So this is going to take in an array of these functions that go from an action to a maybe of state of app state unit. Okay? So now that we have those, we're then going to take an action in. And what we want to return here is an actual well, since it's really just these, I guess, see how we're doing this option here? We don't really want to do that option. We want to keep that in the maybe, I think. So then we'll do state, app state of unit. Okay? So now this is what combineReducers does for us. And now we do not need to do anything here. So we can get rid of that option since we want to keep the maybe and return that maybe out to our root reducer. We don't need this. Why don't we need this? Why don't we need this? So we have our reducers. And what do we want to do? We want to apply our action to it. So all we need to do, because our reducers at this point, when we get here, are going to be functions that take actions, right? So I think that's what we want to do. And I think that's it. And I think we are fixed now. We're not. Okay, so reducers.executeWith is not a function. Oh, I know why. Goodness gracious. Okay, so let's jump into here. And the reason why is our root reducer itself, this returns a maybe. Remember? We changed it to where this reducers, when we do combineReducers, is going to return a function that returns a maybe. And actually, this is not going to return a maybe. This is going to return a first. So what we really want to do is delete to M Well, there's two things we could do here. We could do this dot value of, right? We'll do a dot value of, and just call that, and that's going to extract the maybe from inside of the first. It's going to just take that right from the first, and it's going to return the maybe. Now, when we use monoids inside of the crocks library, delete to m, we can skip that value of extraction and use mReduce map, right? And mReduce map will d2m reduce map and get rid of that. What this is going to do, back. What this is going to do is actually extract the maybe from us, because we want to return a maybe, not a first. Okay? So now we have mReduce map. We don't need to do this value of, and actually we don't need to do any of this anymore. This is all taken care of for us. Now it's a real bummer that this reducers is there, because we could make this, and let's do that in a minute. All right, let's get this working, and then we'll go through and make these two functions. createReducer. Oh, we also need createReducer. So what createReducer is going to take is an object of strategies, okay? And then we're also going to take an action, and then we're going to return, you know what? A reducer. Because remember that a reducer here, and I think we can do the same thing here. Yep. So let me close this real quick. So if we look, the reducer is a function that's an action to a maybe of this. So same thing here. We can get rid of this. And this is going to pick one reducer out of it, right? So, I mean, that reads pretty well. That makes a lot of sense for combineReducers. You give me these reducers, I'm going to give you another reduction function, or I'm going to make it a reducer function, right? So anytime you see this reducer, it's basically, and let's do action of A. All right. It's basically just going to give you that back, right? All right. So here our createReducer takes an object and gives us a reducer back. And that object is this strategy pattern that we have here. So that's what's going to do the picking and do all of that. So now let's get our index file working. Where is that? So let's look at index. We'll just open that up here. So remember, this is actually taking a maybe and giving us a maybe back. So instead of doing this execute with, if two things don't happen, for instance, if the action isn't taken care of in any of these reducers, we'll get a nothing back. And if any of the things that do return something actually return something that's not a state, then we're going to get a nothing back. So what we want to do is we'll use execute with the actual point free function, and then we'll execute that with previous state. Okay? We need to bring that in, and let's do that from here. We'll do execute with, and we'll bring that in from crocks state execute with. Okay, that's just a point free function that'll take a state and run execute with. But if all of this fails, we can't send back the reducer. We can't send nothing back. It's going to say no, no, no to that. So what we need to do is then option this, and we'll option this with the previous state. So if we ever get a nothing back from any of our flows, we then just return the previous state. This will get rid of weird errors. This will get rid of all kinds of issues. And all we did is just define it with types. So now we're working again. But now we have a really nice system that takes care of all of our issues for us, making sure that we have the proper types, and we don't need to set up these switch cases. We move that into this function. All we need to do, so now, for instance, we're making this add to do. As soon as we have something that's an add to do, it's just a matter of pasting this in, add to do, right? Oops. And then putting in add or whatever it is, right? But we're not going to do that yet because we need to actually, and what time is it? Perfect. All right. This is working out great. All right. So now we have the reducer, and all of the reducers that we put together, we're going to put together like this. Oh, and it looks like a bunch of new people have shown up. So again, just like I tell everyone, if you got any questions, you want some explanation on something, want me to talk a little bit more, I'm doing this for you. So please don't miss the opportunity and go ahead and reach out and chat or something. I'm always happy to answer questions. One of my favorite things to do. All right. Have a sip of coffee. And now that we have all of that going, we now have kind of a nice flow here. Now that we have these helpers, now that we have all of this, we really don't need to think about this flow anymore. It now just becomes part of the state. And through all of, we get by using our own combineReducers function, we get back the benefits of using the React one or the Redux one, being able to like separate and combine a whole different file of reducers, except we're not limited by the namespacing opinion that one has. So I don't know. It seems pretty nice to me. We'll see how it goes. And all of this can change, right? We also went ahead and did these action creators. So now we don't need to think about, oh, do I put that in type or payload or anything like that? We just give it the type, and then it gives us back the function that we need to actually put the action in. Okie dokie, artichoke. Okay, so before we're able to add these, just make sure this still works. Excuse me. Goodness gracious. I had a salad for dinner, and boy, oh boy, is it doing a number on me, Tum. So the next thing we want to do is get the ability to add some of these, right? We want to make sure that we can add to-dos and all of that. We probably won't get to the ID stuff because we could do some really neat things with the IDs now that we have this set up. Different ways of generating them, different ways of making sure that we're not dealing with internal state, things like that with this setup. But we might not get to that today. The first thing we need to do, though, in order to add things is actually put a component in. So let's go ahead and we'll add an add to do component to do, and this will be a JSX. And now that we have that, we'll just pop into here. We'll grab this. I want this and this. Okay. We'll probably want that class name in there or something like that, but who knows? Who knows what we'll do? Now, if we look at their example, this is kind of where my opinions start to shine through. And I'm really sorry. I'm very opinionated about this stuff. But if we look at their add to do, to me, doing a let like this is very, it's not very, how would you say, conducive. No, not conducive. This just seems like doing it just for the sake of doing it, right? Like setting up this let and having internal state and then us having to manage that state. To me, I know I'm a functional programmer, but JavaScript has a wonderful way of dealing with state like this, and it is in an object. So to me, this seems like we're just doing this just to do it, when we could, while we're in JavaScript, utilize parts of JavaScript. Now, I'm not a big fan of class like everywhere, but whenever it makes sense, you got to go with the right tool. So I'm sorry if this makes people sad to see someone like me doing things like this, but yeah, component. It's just to say that classes have no use or things like that just seems silly to me when they do. Like they are built for doing things like this. And a lot of times, notice, so basically when I have a reference or I'm doing things like that, a lot of times I'm going to have to deal with state or things like that in this component. Yeah, it's nice to get away from that, but the reality of life is sometimes you got to get a little dirty. So instead of trying to say, well, I'm making these stateless components, this is not a stateless component. This has state, and there's the state right there. So why mask that it's using state by trying to make it look like a stateless component? Anyway, I am full of opinions. But I try not to stand on dogma just because I'm a functional programmer. Doesn't mean I don't use classes. I mean, goodness gracious, it's a wonderful feature in the language. All right, so let's go ahead and we'll start every function with a render function. So what we want to render, and let's go ahead and export default, and we're going to default this to add to do. So that will bring that in. And let's just say we'll do a return. We'll do in H1 of Jello, right? Wow, actually no one dropped off. I thought after my little my little ranting about classes, people would have dropped off, but interesting. Okay, so now that we have that, let's go ahead and bring that in here to, say, our app. And we'll do the same thing here. We'll do add to do. And here we'll do add to do to bring that in. And down here, let's go ahead and do our add to do. Okay. All right. So now we should get something back that's an H1 that says Jello. Okay, cool. So we're all hooked up there and everybody's happy. Happy as Larry, as they say. All right. So we don't really want an H1 that says Jello. What we really want is a form. So let's go ahead and we'll get rid of this. And we will do a, I know I probably shouldn't, but I really like doing those parens. And we'll do form and we'll do an onSubmit. And on submit, we want to call this dot onSubmit. Okay, just for now. We could have done something like passing an action in and things like that, but that's ridiculous. No need to add that complexity now. There's all kinds of great patterns for adding complexity if we need it, but really we don't need it, so what's the point? We'll just go ahead and do an onSubmit. And what are we going to do with this little guy? Who knows? For now, we'll just do console.cry, console, or what is it, CL. And we'll do submitted, just so we have something there. Little bit of something anyway. We'll jump to the end, do this. All right. Now that we have our form and we have our onSubmit, we need a button to actually submit this form, right? So here we'll do button and we will do type equals submit. Submit. Okay, and for the text, we're just going to do add to do, right? And then we close out our button. All right, let's see what this looks like. The other thing we need to do, because we're going to get an error here as soon as we... All right, so one thing we need to do is take the E from here, right? Oops. And from there, we want to, at the very end, call e.prevent default. So that way it doesn't actually submit the form. Okay. And that'll reload. Now we just get submitted, right? Submitted, 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 submitted. So if we were to be in here and hit enter, we don't have anything to hit enter. So let's get an input in there. All right, so let's do an input. Okay. Input. And let's do a ref is equal to, and we're going to take some EL, and then we will assign this dot input is equal to EL. Okay, so now, oops, we need to close this off, right? Does all this make sense? This is just silly React stuff, right? Now, the second we go in here, let's do a console.log and we'll look at values. So we'll do df this and we'll go this dot input dot value. And let's not do that. Since we're going to be using the value in here, let's do input and we'll grab that off of this. Okay, so now we can just take the input and look at the value. But of course, we're going to have a problem here. It's going to throw an error, right? Boom. We don't have a this. And it never got to, because it threw the error, it never got to our prevent default. So since we can get errors there, let's make this the very first thing. I disagree with that, but we're going to do it anyway, just so we can see the errors. And here we have all kinds of issues, right? We see that we have the issues. If we hit enter, we have the issue, enter, enter, enter. And that's because we don't have this here. So now let's go do a constructor, right? Constructor. And with our constructor, that's going to take in props, and we'll do our super props. And there we have that. Now let's do this dot submit, or on submit is equal to this dot on submit. And we will bind it to good old this. Okay, and that of course is going to clear up our error. Boom shakalaka. Now we can do this all day long, but notice we have no value coming in there. So we'll be like hello, right? And or with a P, I guess. Let's make that hello. So one of the things we want to do is always clear this out. Let's see here. Let's move this back downstairs. So what do we want to do? What we want to do here is we'll say if input.length. So if there's length to this, go ahead and log it. Otherwise, we won't. Okay. And there we go. Give it a save. And if we go enter, 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 it didn't log. But if we're like hello, it actually did nothing. Why did it do nothing? If input.value.length. Okay. Sorry about that. Okay. So now it doesn't log anything. And if we come here, we'll just say happy. And now it logs. The other thing we wanted to do is actually clear out. So now since we have input here, let's do input.value is equal to nothing. And that should clear it out after doing the log. So we'll do happy, hit enter, and it's cleared out. Boom. We now have a way to input stuff. But what we really want to do is if we look here down at this, we do our little connect and we do all that, but we're just going to pull dispatch off of here, right? So we want to be able to dispatch this in off of props. So here we can just do const and we'll do dispatch. And to do this, we're going to have to connect this up to get this dispatch function. We could do the map to props and do things like that, but I mean, do you want to? Nah, we'll just do it this way. Maybe we'll go in and fix it later, but this is down and dirty. It's just a nice way to do it, I guess. Because we can do it kind of in this fashion too, where we do map dispatch to props, right? So we could do it this way. And you know what? Let's do that. Well, but we don't really have any state coming into it. So let's just leave it like this. That way we don't need to pass undefined. Okay. So now once we do this, we can say dispatch. And we're basically just going to do the same thing that they do here. We're going to throw that in. And it doesn't really matter what we put because we don't have the action set up. And this is going to be a wonderful test because it's going to tell us how our stuff works whenever we don't have an action handler to handle it because we never set up that add to do. So this is a good test for us. Okay, so if everything's good, we want to dispatch. And what do we want to dispatch? We want to dispatch a add to do, and let's do okay, and now we can just come into here And here we'll just do title, right? Because now we can get our title in there. Boom. And we need to bring in add to do. So how did we do that on our other connected bits? Boom, boom, boom. And then we'll get rid of this. Oh, we're going to need connect too. Goodness gracious. So we'll bring connect in too. Okay. And here we need to bring in add to do. Okay. So now we have our add to do, which is going to actually dispatch the action, do all of that. But now we need to set up our connect. So we'll connect to here, do some of this, delete to the end, and then paste that in there. Now we have connect, and we have one more error. I think I know what it is. Yep. So we need to actually throw dispatch inside of our prop type. A lot of things say don't do this. Go ahead and put in the rule to exclude it, but I think that's silly because it is something that comes in from our actual props. So let's go ahead and we will do a static function here. So let's do static, and we'll do a static get, and we'll call this prop types. And that's going to be a function that returns, what are we going to return? We want to return dispatch, which is a prop types.func. Now, let's also set up a default prop. So if this doesn't ever get passed in, we don't want it to error. We don't want to do things like that. Remember, this is JavaScript. We want to do reasonable defaults. So we'll go here and go default prop. And for default prop, we're going to return a prototype. And that will get us basically a no-op, prototype. Okay, so now if we never pass in, so even if, check this out. I'll show you kind of what this does. So let's not do the connect. Let's just, we'll GC this, and then we'll get rid of the connect and get rid of this. And when we run it, notice we didn't get an error or anything about the thing not being provided, right? And that's because, hello, there's no errors, there's no nothing, because if this dispatch is never provided, when you use this default props, it will go ahead and give us back a function to call. So no more undefined is not a function. It just takes care of itself. You'll know that there's a problem whenever, as you're developing, because your thing isn't being called. But now that we go back here, we'll say hello, and we hit enter. We need to verify that it's actually, well, we don't need to verify. We can do things like that. It makes sense that it is returning and dispatching the action. But you'll notice that we're not getting any errors or anything like that. All right, so this is ugly as sin, though, and that's because I have things that strip off all of the styles on this. So let's go through, what time is it? Yep, perfect. We got about a half hour, which is great. That'll get us time to style this out and get in our bit to add that. So let's add a couple class names. So for this, we're going to do class names is equal to, and let's call this add to do, okay? And now for this import, or input here, we'll keep that. Let's go to the end, hit this, and we want this, we'll go class name, and class name is equal to add to do, input, and we'll do the same thing. Oh, let me just do one of these, replace enter, and enter, and then we'll bring this here, and we'll do class name with that being button. So now we have a way to control each one of these. All right. Now let's get some styles, some Miley Stylists, or not Miley Styles, what's her name? Julia Styles. Let's get some Julia Styles in there. We'll come up to here, we'll jump to less, components, and then let's add an import of add to do. So we'll put this in and we'll call this add to do. Give this a save. It's going to create an error. That's fine. So here we go here and do add to do dot less. All right. So now we have that. Oh, let's go ahead and close that out and we'll replace that. So let's go add to do and we'll do it as a class name and add to do. Let's look at some of the helpers that we have. So we have a grid. All right, so let's add a grid row, right? Dot grid row. It's like skid row, but different. We'll add a grid row. And that should get us the flex. What's going on here? Add to do less. Boom, boom. There we go. Sorry, just had to save it again. Okay, so now we should have something that has a flex on it, right? So this is to do list. I don't see, oh, not to do list. We want add to do. So that gets us our flex box. That puts everything there. And we want to take this and actually stretch it to the right. So what we'll do here is we will take our input. So we'll do this with input. And then we're going to do flex 1, right? And that will flex it and stretch it. I should make a helper. All right, see, so that stretched it to the end. I think this is a little big here. Let's get some spacing in there and see how big that is. So speaking of spacing, let's get some spacing in there. We will do a spacing helper and let's do 1 rem on the top and bottom and we'll do 2 rem on the sides, okay? And that'll get us 10 and 20 on a normal font. There we go. And now that we have that spacing, man, that text is kind of small. We could maybe make it bigger. Actually, we don't need this open right now. We'll see what goes on with that font. Maybe we need it bigger, maybe we don't. Who knows, right? I guess that's all we need for this. This is all we need. Oh no, it would be nice to have a border. So let's do a border. And let's see here. We'll do 1 pixel and we'll do solid. And we will do gray. No, that might be the wrong one. It is the right one. Okay, so now we have a gray border. Let's go ahead and give that a border radius. And we'll do a border radius of 3 pixels. Okay, so that'll make it a little smoother. Oh, that looks pretty nice. That's a nice gray. I like that. I wonder what silver would look like. So let's look at silver. Okay. Ooh, I like silver better. Let's stick with silver. Okay. So we have silver that we're going to use there. And now we need to do something about this button, right? So let's take this button. And one of the first things we want to do is let's give it the same spacing, right? So we'll do 1 rem on the top and bottom. And then we'll let it breathe on the sides with 2 rem. See what that looks like. Oh, that's much better. Okay, so now let's also give this a border and a border radius. This is something we could add later on. Maybe depending on how often we use this, we'll not copy and paste it. But we don't really want that silver. We want this to be blue. And we want to do a background of blue. So we'll do BG blue. And that will be our background of blue. And let's go ahead and do white. And this will give it a color of white. Okay. All right, let's actually make that bold. So we'll do bold. All right, that looks a little better. I kind of like that. I don't like how butted up against the thing is to that. So let's not do that. Let's actually do a, we have our spacing, we have that. Let's do a margin left, margin left, and we'll do a margin left of, how you say, let's do 1 rem for now. We can up that to 2 rem, see what that looks like. Let's see what it looks like at 2 rem. Okay, and we'll do inspect. And button, who's got my button? Let's make this 2 rem. I like 2 rem. Let's do 1.5 rem. I like 1.5, much better. All right, so here we'll do this at 1.5 rem. Okay. Now, I really think this is too big. So let's see, what is app at? App is at 60. What's it look like at 50? Maybe 60 is fine. 55 rem? 60 is fine. All right, so we'll keep that at 60. Let's also do a little something. So we'll do the normal border like that, except we'll do border right to be navy. And then we'll, navy. Oh, that's adorable. And then we'll do border bottom to be a navy as well. All right, so that gives it a little bit of depth, makes it look a little interesting. We could put some shading or something on there. Ooh, the other thing we want to do is cursor. And this will be pointer. Okay. All right, so now we have our pointer there. We have all of that. If we go hello and hit enter, it actually sends it, does all that. Okay. So we got that styled. We got all that looking good. I think we're done with the styles. We can move on to the fun stuff now. Okay, so now let's jump into a little bit of this. Let's do a placeholder here. Placeholder. And we'll say delete to that. And we'll say enter a title. Okay. So we have an enter a title. I don't know about this font. Yo. We'll have to see what's going on with that. Let's make sure our actions still work. So we're still getting our normal actions resolved. Everything does that just fine. Okay. So I think we're good. Like, I can't think of anything else. Can anyone else think of anything else that we need to do, maybe? Something you'd like to see? I'm going to hook up the action, but I mean on the UI, is there some input, something you think we should add to this? All right. Looks like we good. Ah, James, I like the way you think, my friend. See, and that's why I ask things. And you're right, we're going to do the padding because padding is a better way to push edges. So you must be a web developer or something. Maybe a JavaScript genius. Who knows? I know. All right. So let's come here, and James is 100%. He said margin top on the app or padding. And let's give it all kinds of breathing room, you know? So we can come into here, and we'll do a components, and let's not do it on the app itself. I like that the app is pushed up because we can make it a hero and things like that. Let's just do that here, and we'll do a spacing. And we'll do a spacing of 2 rem and 0. Because we don't really want it to be on the left and right. We only want it to be on the top and bottom. Boom. Oops. What'd you do, Ian? What's going on there? Did you do something silly, you little silly goose? Oh, yep. Some people like to use... there we go. How's that? Does that look a little better? So we could probably, now that we have that there, we could push this up to the top. So what if we get rid of bottom and top? That looks better. So let's jump into to-do list. Okay. We'll just jump into to-do list. And here we'll do a spacing of 0 and 1.5. Okay. Nope. It's not what you wanted to do, you silly goose. You wanted to do that here on the list. Okay. And there it is. All right, so that looks a little better. We got our internal spacing. We got all that. I still don't know about this font size. We might change that. But with 20 minutes to go, I think we're going to do mighty fine in getting this working. Okay, so now let's hook up. We already have our action. We've been sending it this whole time, but we haven't done anything with it, right? So now we need to actually set this up to add it. And you're going to be surprised how simple this is. We have a lot of things going on in here, right? But all we really need to do, we'll just get this working. We'll just do add or create. Let's do add. Okay. And this is basically going to take, takes an object because we'll have that title, right? And then here we'll do add. And then we're going to bring that title in, and we need something to map over the to-dos. So df this. So we have a title, and we want to take the to-dos that we have. So what we want to do is not take this title in at all. We need to have something that will default for us because we're not putting in the completed. So let's create a little function. We're going to bring in default props. And what default props does, we can actually look at this here. Let's go crocks, and here's the crocks docs. We'll go to functions, and let's go to helper functions, and we're looking for default props. Basically, what default props does is you have an object and you give it an object, and if those things don't, it'll take another object, and if on that other object the other ones don't apply, it'll add those as defaults to it, right? So we want to set this up. We'll create something called default to do. Default to do. One more thing we have to do up here, and this will be default props. And this is where the fun stuff happens. Because remember, we're just inside of the state monad. So we can work on this state however we need to work on it, and just it'll take care of it for us going forward now. So here we'll do default props. And we can just put in what our default props are going to be. So if title's not provided, we want that to be an empty string. If completed isn't provided, then we want that to be false. And now we'll always have these defined on all of our actions that are created, right? Okay, so. To do our add, what we want to do is create a function, compose, and that'll default props. Do we need to compose it? So we need to take a function. Yeah. So what we want to do is we're going to get back an array here. So we just want to concat, super easy, default to do, and pass in to do. Okay. Where do we get to do from? df this. We get it from here. So this will take a brand new to do, and okay. So that comes in from there, and we do our default to do with the to do, and then we chain in the commit, right? So a couple things I don't like about this, like we could very easily do this all as a composition, like a point-free composition, instead of doing all of this, and maybe we'll get to that at some later time. But basically, what we're doing is we're going to call map to-dos. That's going to take in an object that represents our new to-do. Then we're going to apply our default to-do to that. So that way, if none of these things are provided, they will be provided for us. It'll default it to whatever those are. And then when everything's said and done, we're going to commit that. And what commit does is that takes a commit. That takes an array of to-dos, okay, and gives us back a state, app state of that. So this is where we get our state of app state and all that. It actually comes in that way. When we do this map to-dos, this is going to take a function for this map to-do. Let's just get some of these in here so it makes sense. This takes a function that will take any type A, that's going to take an array of to-do. And up here we can do one of these. We'll just say a to-do is a function, is an object that has, what does it have? Right now it has a title, which is a string, title. And it takes a completed, which is a Boolean, right? So that's what defines a to-do. We'll say to-dos just so we can abbreviate this, is just going to be an array of to-do, right? So here, this is going to take a function that takes to-dos, and then gives us back a... It's going to take that function that does all that. It's going to map over it and then give back the result of that. So it depends on what this is giving back, because it doesn't need to give something back. So we'll just say it takes the to-dos and gives an A. And then that's going to give back a state of app state. Of A. Yep. Right? So what happens is the to-do happens. It does all that. So what's going on here? It just so happens that we are bringing back an array of to-dos by doing this concat. And then that's going to call this commit, which then comes in and associates whatever we give it to the to-dos. So this needs to take an array of to-dos. So this can be to-dos. Okay, if that makes sense. And let's go nice. Okay, that did nothing because we didn't hook it up. I'm not going to worry about this flip complete and things like that because this is not how we're going to handle this as soon as we get the ID in. We're not going to do any of that, so I'm not going to bother putting signatures or anything on it like that. All right, so now in our to-do, we need to actually set this up. So this is how easy it is in our new pattern. Okay. And that's it. Just works now. Now we have everything all set up. So when I go nice, it throws an error. That's great. All right, let's see what error it's throwing. I wonder why it's doing that. So the first thing we want to do is jump into here, and I knew that should have been in the beginning. I don't know why I kept moving it up there. Okay. We'll see what the error is. It's probably something real silly. Semi-groups of the same type. Okay. So the reason why we're getting this error is in order to do concat, I need to make sure that it is inside of another array. So we'll just do that the easy way. And for now, we're going to have a better pattern for this once we get it. But let's just get this thing working for now. Okay. Now it'll work. Great. So that's it. We now are able to add things. Pretty exciting stuff. We got that little error there, but for the most part, everything is just working the way that it is. We can go and on the new ones, the completed and all that's in there. We have everything all set up and working with our state monad and our reducers. Now there is a bug here, and this is because of the ID. So say I have nice, watch what happens. Both of them, because we're actually deciding if I did great. Same thing happens with great. Because we're selecting the record that we want to do the completed with, we don't have a unique ID for these, so it's just going on and keying off the title. Right? But, I mean, that's pretty much it. Looks like we had a few people drop off at the end there, but got any questions or anything? I mean, this is pretty much good to go. We're not going to do anything else to it until next session where we'll be adding the actual ID. But did this make sense? Any questions before I sign off? Speak now, forever hold your peace. Or put a comment on the video or something. I don't know. So here we'll take an object and now we're guaranteed to have a to-do, because it'll fill out the other things. Hey, David Wells, thank you for showing up. David asks, just got here, what does ADT stand for? ADT stands for algebraic data type. So what we mean by that is instead of doing a writing out flows for like capturing disjunction or control flow or things like that, what we do is move all of that behavior into these types. And these types are based on certain algebras, or these methods, I should say, that are on the types are based on well-known algebraic interactions. So, for instance, you might hear things like monads and functors and all those crazy words. These ADTs provide ways to use the methods to work on those types of data structures, right? So in this one, we're really only using two ADTs right now. We're using this state ADT, which allows us to basically capture state, lets us work on state in a lazy way. And then later on, we can provide it state and it'll get back the result, kind of like a state machine. And the other one that we're using is called a maybe, and that gives us like a sense of disjunction. So what that does for us, I don't know how familiar you are with algebra or with Redux. But if I come into here, and you'll notice the reducers that I use here, they basically, they say nothing about state. It's basically things that only work on actions, right? So if we look at our helpers function here, it comes in and we have our createReducer. This basically gives us back an object that will give us back a reducer that is a maybe state of app state and unit, if that makes sense. Well, it may not make sense, but go back and watch it and it'll make sense. But you'll notice the reducers that we're using here, they don't take in the Redux state. They don't take in the Redux state at all. And that's because if we look at our root reducer here, this handles the actual state for us. And all it does is pass in the action to our reducers. Oh, perfect. I'm glad that you use it. So you'll notice the difference here. Crocks it's not really similar to Ramda, but it is in that same vein. Crocks is pretty much implementations of, it's mostly around these algebraic data types, right? So like we have the state algebraic type and things like that. So while Ramda is for what I like to call the category of JavaScript, this is for working in other categories and lifting things from Ramda into these other types. And Crocks is basically centered around creating these types. Not all of them are documented, but these are the types that we ship with right now. And each one of these has its own effect and its own thing that can be worked on. It's a fun little library. I only say that because I built it, but well, not built it, but had the idea around it. So what this allows us to do is completely extract away or abstract away the handling of state and lets us work on our state in a lazy fashion, right? So instead of like having those reducers that do things like that, I can create, and this is a bad example right now because we're in the middle. We'll have to refactor all this and make it a little easier. Easier to, how would you say, capture patterns to make it good to go. But what this does is lets us define like how to work on the state that Redux is providing. And we say, do this, do this, do this. And then when everything's said and done, we have a way for the state to transition. And then at the edge of our program, here in our root reducer, this is where we actually put the state. And if we don't have any state or nothing came back to work on, then we just give the previous state back. So, yeah, this code is in a repo. I will be adding this. The original code is, so let's go GitHub, EvilSoft. Repositories, to do plus. So let me just paste this little thing in here. Right now, if you look at it, it's basically, this is the branch from last time. Whenever you look at it, probably tomorrow, there'll be another line here that will have a link to this video plus the branch on this repo. That's going to be 0x01. But this is the code from yesterday or from last session. And it'll tell you how to run it, things like that. Yeah. Sources in here. Here's all the JS. So you can see kind of, you know, what we did. Follow along as we go along. For instance, here's the reducer. This is the old way. So if you notice, last time we were doing this very Reduxy, the same way you would expect it to be in Redux. Is it private? I hope it's not private. Wow, why is it private for you? I don't pay for private. This is usually... Huh. Can anyone else verify that? It looks like for David, do you mind if I call you David or Mr. Wells? I don't know if that was your dad or anything. Yeah, I don't think it's private. It is? Oh my goodness. This is super embarrassing. Why would this be private? Huh. Who started it? I wonder how these people can star it if it's private. I wonder if GitHub's having issues right now. What the? That is so strange. Huh. All right, well, I need to figure out what the heck is going on here. Huh. This is pretty silly. All right, we got our features. We got that. Make this private. But it says it's not private. Oh, is it this? Is this what's private for you? Huh. Yeah, I wonder if GitHub's having issues right now. Because, I mean, you see it's not private here, right? Like, it's saying, hey, make this private, but I need to upgrade my plan. Yeah, I don't know. I'll have to figure that out. I'm so sorry that that's not working for you. But anyway, how embarrassing is that? It's like 5 embarrassing, you know? Which is pretty darn embarrassing. Well, boogers. Boogers, boogers, boogers. Does this link even work? Yeah, that works. Huh. Well, I mean, the thing I was trying to show you, I guess I'll just show you now. So you can see, now this is master. Let's go to 0x01. Then we'll go JSX, and then we'll go data reducers, and then we'll go into to do. So we were doing this before, pretty much using the switch case, but now we just set this up to using this helpers function. We go in and use this createReducer, which will give us back, make sure that everything, it basically applies our payload to the function and does that switch case for us using the strategy pattern. Yeah, I don't know. That's really strange. Let's see when I click on it, what happens. Oh, I'm getting a page not found. Huh. Well, I'll be... Huh. GitHub.com, yeah. EvilSoft to do plus. GitHub.com, EvilSoft to do plus. Gosh. Yeah, I don't know. Let's try it again. Yeah, from that link I get it too. I wonder if it's something that they're doing. TypeScript with FP. Sure. I don't agree with TypeScript in FP. I think it's a stopgap. And the reason why is whenever you're doing like curried functions and things like that, like the whole benefit, if it could do better inference and actually like dig into these types, implement something great with higher kinded types, things like that. If it could actually do that stuff, I think there would be a real benefit there. But the thing is, I'm not, and don't get me wrong, I'm not a TypeScript engineer. I know there's a lot of people out there that are TypeScript developers. I'm an actual JavaScript developer, right? Like I don't do TypeScript. I know how to work without having static types and make quality code that works just fine. Like I don't need to have that extra step. I'll do a lot of things with specs and things like that. And I don't know. I just think personally, my opinion is that TypeScript is just a stopgap. Like it is great for object-oriented programming, but I look at people's implementations and what they have to do to define things. Like if you look at the definitions for Lambda, it's ridiculous. And then on top of that, once you build your domain structure, making your own curried functions and things like that, they don't work out. And most of the time, you're just putting it to any anyway, just to get it to work. So what's the whole point? And then you just end up with all these definitions that you also need to do. So me personally, I have no problem with static types, but I don't think that TypeScript is the solution for us. And I have mad respect for the people that are using it. I would never use it in my flow. There's, in my opinion, no real benefit for it. Other than one thing that bums me out, one thing that I might use it for, or put them into, at least for crocks for, is so people can, a lot of people use that code IDE these days. And it does some really good things with, being able to document, like tell you what the parameters are and things like that. I'm a Vim user. I don't use code, but there are a lot of people that do, and I would like to help them out. But at the same time, I don't know. TypeScript is great and all. Flow's even better, but both of them are really just a stopgap. And to be honest with you, I see it more like CoffeeScript. You're not really a JavaScript developer, and I hate to say this, but you're not doing JavaScript. JavaScript doesn't have static types. You're writing TypeScript. Now, if I were to pick a language that wasn't JavaScript, oh, interesting. I wonder how that got in there. Thanks, James. I wonder. That's weird. TypeScript. So I don't know. If I were to pick a language that's not JavaScript to code in, I personally would pick PureScript because it is a lot closer. You get the static inference, things like that. And don't get me wrong, TypeScript is great for object-oriented programmers. I just don't see the benefit. It just seems like a real pain in the bum, especially when I see people go on and on, any value from it. I would say for now, just learn how to actually do JavaScript, learn how to do reasonable defaults, learn how to deal with data flow, things like that, and you'll be able to move quicker. And I highly recommend, doing specs like for that. And I mean, that's just the way JavaScript is. And don't get me wrong, if you use TypeScript out there, things like that, mad props to you. Like, that's so awesome. It's just not for me. And I don't think it's really, it's more of a stopgap. What I would really like, to be honest with you, if we could get something in there, get something that would be able to figure out these. Like if I were to put these comments in, if it could actually do inference on these comments, I think that would be amazing. Now, this is something we could do, right? If we had something like this, it would actually fit with what we're doing and how we would do declarative programming like this, in my opinion. You know what? The other thing we're going to do next time is, I don't like calling this strats. We can make this a complete point-free function, and we can make this a point-free function. So we'll do that next time by using flip and things like that. No need to do this like that. Actually, we could do that real quick, because this would just be this, right? And then let's do flippity flip flipperoonie. And this is just a combinator that flips things, flips the arguments, the context. So this will be combinator, and this will be flip. And then we want to flip these, and now I can get rid of that and get rid of this, and that should still work. Okay? And it doesn't. Why doesn't this still work? Why doesn't this still work? Huh. Yeah, maybe we can't. Can't resolve crocks. Oh, combineReducers. Sorry. Okay. Yep, so that still works. All right, so David Wells also asked, where should I look to get started with ADTs? There is a really cool guy. I don't know if you're familiar with him. He's one of my favorites, but there's this guy named Dr. Boolean. That says old. This is a wonderful book. I've only read a few chapters of it, but the chapters I read were very good to me, and everyone I've suggested this to has had nothing but good things to say about it. Also, if you're an egghead person, I know I have some courses on here, the state monad. There's also, I believe that person. Yeah. Yep. So this is also a community. So this is completely free. This is probably going to put in those special characters. So if it puts in the special characters, I'm sorry. But yeah, this Dr. Boolean fella is pretty good. He's one of my favorites. He's very, very smart. There's also Tom Harding. Tom Harding this guy is amazing as well. He created this. So check this out. He goes into Fantasyland. All right, I don't know why this is putting in those spaces. Thank you, whatever you are, YouTube. But this feller here, he's really good. And this is all based on Fantasyland. So Fantasyland is, this is what defines how to use these ADTs inside of JavaScript. So yeah, this is a good place. Now, you don't want to get hung up too much. I would say just download. There's a lot of libraries. Like if you don't want to use mine, Crocs, download. There's so many of them out there. Like Fluture. Fluture's a good one. This gentleman is really great. He's very helpful. There's also Getter channels. That are good. Fantasyland, Sanctuary is wonderful. All of these people in these channels are super nice. And there's also a Slack for functional programming that's really nice. There's a lot of stuff out there. So yeah. I mean, that's really all I have. Let's see, were there any other questions? Dr. Boolean, thanks so much. Would be cool. Yeah. ADTs they're amazing. Well, it's not that they're amazing. They're just a different way of programming, right? They're a completely different way of programming. It's a different way of thinking. It's kind of like going from procedural programming to object-oriented programming. Yeah, you can do the same procedural stuff, right? But object-oriented is a whole different way of doing it, which gives you other things. Oh, what did Eric Elliott do here? Interesting. Huh. Oh, he put a comma in. Okay. Yeah. So that's all I got. If there's no other questions or anything like that. Cool. Alrighty. Well, I'm signing off. I'll be on same time next time. It's 6:30 PDT when I start for Pacific time in the daylight savings. So yeah, that's all I have. Thank you guys so much, and gals. Goodness gracious. Thank all of you for coming and checking this out. And I'll be around again later.